Hi, I'm Selma Banawan. I'm back with the pre-release material for paper 22, the May-June 2021 paper. All right, and this time we're doing it in pseudocode. Okay, as you know, the pre-release has 3 tasks and they're about a train station. We want to display how many tickets are left. There are trains going up the mountain, 9 o'clock, 11 o'clock, 13 o'clock, 15 o'clock, and trains going down the mountain, 10 o'clock, 12 o'clock, 14 o'clock, and 16 o'clock. So this is the pseudocode for task 1. We have the first 3 lines are arrays that are storing the data for the trains going up the mountain. The next 3 lines are 3 arrays which will store the data for the trains going down the mountain. Then we have a print statement, okay, to show the titles of the columns that are going to be printed in our train station table. We have a for loop for count, and we assign count from 1 to 4, print the times up the mountains and how many tickets are left going up the mountain, print the times down the mountain and how many tickets going down the mountain, and next count. After that, we have task 2. Task 2 is about 50 lines of code. All right, so here are the first 13 lines of code. Of course, if you put the end while in there, it's going to be 14 lines of code. The first line of code talks about ticket cost equals 25.00. So we have a constant, and that constant is of type real. It stores the cost of 1 ticket going up the mountain or going down the mountain. The second line is a variable, which is kind of like a flag for the while loop. Selling tickets equals y. The third line, while selling tickets equals y do. And the rest of task 2 is all inside this outer while loop. So the rest of task 2 will be indented, okay, until at line 49 we have the word end while. So the code from line 4 till the end while, okay, is basically prompting the user, what time would you like to go up the mountain? Input the time, validate the time. While the time is that they said is not equal to 9, and it's not equal to 11, and it's not equal to 13, and it's not equal to 15, that means that time is unacceptable. So we print error message, what time would you like to go up the mountain? And we input the time and while. After we've validated the time, we will run a short for loop. The purpose of this loop is to extract the index that corresponds to time up. So let's say, for example, the user input the time up as 11. This for loop will iterate through the times up train array and check. Trains up times of 0 is equal to 9. Is that equal to the time they input? No. Trains up times of 11 is at index 1. So now I've extracted the index that's related to the time that the user input. And that index is 1 if they input 11. If the user had input 9, the index would be 0. If the user had input 13, the index would be 2. And if the user had input 15, then the index would be 3. Now let's take a look at the task 2, the lines from 14 to 23. These lines are asking the user, what time would you like to go down the mountain? Then in line 15, we input time down. In line 16, we start a while loop to validate the time down. Notice the time down has another criteria. First of all, the time down has to be either 10, 12, 14, or 16. Also, the time down has to be after the time going up the mountain, because you cannot input, let's say you decide to go up the mountain at 11, you can't go down the mountain at 10 o'clock. So line 16, basically says while you're inputting the wrong data. So while you're putting a time down that's less than time up, or you're putting a time down that's not equal to 10, and it's not equal to 12, and it's not equal to 14, and it's not equal to 16, that's an error. Choose another time to go down the mountain, input that time and while. At line 19, we start another for loop to be able to perform a linear search to extract the index down that pertains to the time down that the user input. So as you can see, we have an array, trains down times is equal to 10, 12, 14, and 16. Okay, if the user, for example, said they want to go down the mountain at 16 o'clock, then the index down would be 3. All right, now for lines 24 to 31, the user is being prompted, how many tickets would you like to buy? Every 10th ticket is free. Line 25, input number of tickets. Now line 26 has the validation for number of tickets. The number of tickets if it's more than the number of tickets available on the train going up of index up, or it's more than the number of tickets going down in the train's down tickets array at index down, there's an error. There are not enough tickets on that train ride. Choose another number of tickets, and of course choose 0 tickets to cancel, because then their cost would be 0 and they wouldn't be changing any data. Once we've finished validating, then on line 30, we can calculate the cost for one trip. So the cost for one trip is equal to the ticket cost, which is $25, times the number of tickets that they have chosen, minus the number of tickets divided by 10. This is integer division, in pseudocode. And finally, we're going to print a message. You will need to pay the total cost for one trip multiplied by 2, because you need to pay for going up the mountain and down the mountain. So in line 32, 33, 34, and 35, we're basically updating the train table arrays. So we're updating the number of tickets going up the mountain, because now we need to subtract the tickets that were already bought and paid for. And in line 33, we're updating the number of tickets going down the mountain, because we need to subtract the number of tickets that were already paid for. And we're also increasing the money. So we're increasing the money of the trains going up and for that particular index. And in line 35, we're increasing the money that we've collected for trains down money at that particular index for that time. Now in line 36 to 42, or to the next count, so that for loop is basically saying that if the number of tickets on a particular train ride is equal to 0, then change that 0 to the word closed. Okay, and if the number of tickets on the trains down is now equal to 0, then change trains down tickets of count to closed. All right, and then what's labeled as line 43, 44, 45, 46, and the next count, this is a for loop to print the new updated trains tickets table. So after the person has made their purchase, finally what's labeled as line 48, we need to take an input. Are we still selling tickets? Line 47, line 48, is the train station still selling tickets? If it's yes, then what will happen is this entire task 2 will iterate. If the person typed no, then it will go to end while, and we can start the code for task 3. So basically, I've shown you in pseudocode how to prompt the user to buy, and what time do you want to, prompt them for what time they want to go up the mountain, prompt them what time they want to go down the mountain, prompt them how many tickets do they want to buy, show them their total cost up and down, and update the train table. So that's what we've done in the pseudocode. Now what's left is task 3. So I've put the Python code for task 3 because it's exactly the same. The only changes you're going to make are the for loops. So as you can see, there's a for loop at the top, a for loop at the middle, and for loop at the bottom. You're just going to write the correct syntax for for loop in a pseudocode. So from Python, where it says for count in range 0 to 4, you're just going to change that for count arrow to count from 1 to 4. Okay, and then at the very end, you're just going to put a next count. All right, and then in the next for loop, it says for count in range 0 to 3. So you're going to change that to for count and assign to count from 1 to 3. That's all there is to change. Everything else is exactly the same. Thank you so much for watching. I hope this was beneficial, and let me know how your pseudocodes are going. Let me know if you need a flowchart. Have a great time solving your pre-release material. Bye-bye.